All right, in 6.1, on Chapter 6, we're doing more with probability. But in Section 1, we're going to look at probability distributions. And we'll get into describing them, calculating their mean, their standard deviation, that type of thing. Okay? So this first question is not a new topic here. I have some data from goals scored in NHL games from 2010, all of them actually. We saw this in Chapter 5. If I want to show that this distribution is legit, I just got to go through and show that all these outcomes, and there's a lot of them, there's 10. I would certainly want to double check on a calculator that they do, but for one like that, I'm not going to write out all 10, right? You get the idea that those probabilities, they needed to be added together, and all 10 outcomes have to add up to 1, okay? We could head down here and make a histogram. Trying to space these enough so I have the appropriate amount of room to make my histogram. So I should have 10. I'm just going to make the bend width 1. There should be a 2 right here. Ideally, they should be the same size. I didn't plan it really well, and it kind of ran out of room. Which is no big deal. I'll just extend it a little bit. And there we go. All right, so I'm going off of the left side, as I always do with a histogram, and I'm kind of estimating my heights. That needs to go up to about 0.06. This one is up to 0.154. So that's the frequency that one goal was scored in a game. 2 needs to go up to about 0.22. 3 is almost exactly the same, and in fact those look like the most common outcomes. 4 is going up to 0.173, so a little less than 2. 5, just under 0.1. 6 is going up to 0.04. 7, 0.01. And then 8 and 9 are really, really low, as those, there was not a lot of NHL games where there was 8 or 9 goals scored. Oh, describing what you see, it should take you right back to good old socks. I haven't calculated the mean, so I would say from just observing the histogram, I could say mean or median, probably somewhere about 3, maybe a little bit bigger. That's my center. Here's spread. I can tell there's a range of 9. And I'm going to say shape looks to be like a slight right skew. And then no obvious outliers. There's no disconnected parts to the histogram, so I don't think there's any. Okay. It's probability that the number of goals scored in a game was at least 6. Okay, that kind of calculation is just coming from our outcomes of 0.041 plus 0.015 plus 0.004 plus 0.001, right? So that's the outcome of 6, 7, 8, and 9. It's just those added together. And it's like 0.061. So a little over 6% of the time, the teams would combine to score at least 6 goals. All right, I'm going to show you, like mathematically, how to get the average. Okay, now I picked one like this on purpose. So you would be anxious to get another calculator feature. This can be done on your calculator very quickly, and that's how you're going to do it. But this is, you know, as always when you're doing those, well, I should say as always, because we've had times we've gone to the calculator where I don't even show you how to do it by hand. This is one you should know. Essentially what you need to do is the sum of the outcome times the probability that's associated with that outcome. Okay? For example, 0 goals scored is possible. There's the probability that went with it. 1 is like my x, and 0.154 is its probability. At some point, you probably see the pattern, how the two numbers kind of go together in the table, and you're like, all right, I get it. Really, 10 of them? You might be thinking, if there were 3 or 4, that's not so bad, but 10 outcomes does get to the point where you would probably want to be thinking about going to your calculator for some help. Okay? For showing work, it's kind of like that first one. You don't have to write all of these out. You could just do the first 3. That's not a big deal. This one example is going in your notes, so I want to give you all of them because I gave it to you with the definition. But here we go. We're still there's 7, 8, and 9. Okay. Now, even just on your calculator, that's a lot to type in. Which is why the calculator feature will use list 1 and list 2. Okay? I'll make a tutorial for it. I'll show it to you in class. All that mess would come out to about 2.85. So I would say, on average, NHL games in 2010 had 2.85 goals. Almost 3. Okay. I don't know if you guys can pick up the background at all, but if there is the faint sound of people speaking Spanish and madness, I believe there's a couple people outside in the hall practicing for a Spanish skit, so I'm okay. Nothing weird is going on. I'm totally safe. But there's a little Spanish skit practice going on. That's all it is. Maybe, hopefully you can't even hear it. No idea what they're talking about. I took French. So, that's all I got. All right, new context here, but from some pretty similar questions. All right, the probability that x is greater than or equal to 3. This is some grade data from NC State, I think. So look at the outcomes associated with that. That would be 0.42 plus 0.26 would be 0.68. Okay. Now, in very simple terms, that's what it means. 68% of students earned A's or B's. This is going off your GPA scale. A gets you 4 points, B gets you 3, C's get you 2, D's get you 1, F's do not get you any points. Okay? Worse than a C? In probability notation would look like that, right? X less than 2, I'd have 0.1, those are all my D's, and my F's, right? So that's part of section 1, is just calculating probabilities from the distribution. I skipped over like checking to see if it's legitimate, right? If that covers like all the possible outcomes that a grade could be, those should add up to 1. Okay, this doesn't have plus minus, but you actually do find some courses at certain levels of college that may not use plus minuses. It's just A, B, C, D, F. Okay, down at the bottom here, we're going to do the whole histogram deal again. I think that's good to do. Here would be our bin for 0. 1, 2, 3, and that's where 4 will go. Oh, I think the highest was around 0.5, so I'll do 0.1, 0.2, 0.3. Extend this just a little bit to try to keep the levels fairly even though it's a sketch, so they're not going to be perfect. All right, so this bin should be up at 0.02. That's my F's, right? That goes with 0. 1s, those are my D's, 0.1. C should go up to 0.2. B's, all the way up to 0.42. And A's, all the way up to 0.26. Okay, and let's finish today just talking about this in terms of what we see, right? Getting us back to bringing probability to distributions. Okay, so again, when you're describing what you see, this is just like the other one, you should be thinking of socks, right? Describing what you see histograms illustrate a distribution. Okay, so that's what you're describing. From here, without I could certainly, on the first one you couldn't have calculated it, but then I showed you how. So with that table, you could go ahead and calculate the mean. Okay? I think it's going to be something close to 3.5. I'm not going to go calculate standard deviation. Okay? I'm going to get to that in day 2. You don't even know how to do it yet for this type of data, but I'll show you. Looks like it follows a little bit of a left skew. And then really, from a histogram like this, you can't really say much about outliers, but I always like to just add it with it so you get in the habit of speaking to all 4. Because then I'll add to it no obvious outliers. And there you have it.